So the vector between 2 points, we're looking at obviously considering if we have 2 points, a vector between them. So the definition here, if A equals A1, A2, A3, so X, Y, Z component, and B equals X, Y, Z component, B1, B2, B3, are 2 points in space, and the position vector of B relative to A is given by A to B. Okay, so this is OB minus OA, which ends up being the B component, B1, or the X component of B minus the X component of A, the X component of B, the Y component of B minus the Y component of A, the Z component of B minus the Y component of A. Now, just quickly, we've sort of talked about this, but if we think about, I'm going to draw these 3 points here, O, A, and B. If we are considering, I'm just going to draw the vectors here because that's what we've been given. We've been given OA and OB. If we are going to consider these vectors here, I'll use the highlighter so I can highlight over the top. But if we want to go from A, we're going to have to go this way here, and then we're going to go along this to B. Now, this first vector, which we've got, so we're going from A to B, we're technically, let me change to another colour, we're technically going from here to here, and what we can do with this is we can go, well A to B is going to be equal to O to A, not O to A, sorry, A to O plus O to B. This should be refresher from last year. Now, we don't have A to O, but we know that this is equal to O to A, the negative of O to A, because these lines are parallel and the negative swaps the direction. So AB equals negative OA plus OB, which you will notice here is this formula here. Okay, the magnitude of AB is, I've used the modular symbol, or the length of, and we just see that, just similar to before, the individual components, we put them in this formula here and we subtract them. We will do it in the example question, but which is the distance between the points A and B. So let's go to here. We've got, if P is this coordinate and Q is this coordinate, we've got, let's do them both. We've got OP, let me change back to the light blue. OP is going to equal, I'm going to use our, so I've changed, you'll notice the bracket has changed because I'm doing that vector notation that's part of our course. Okay, so we've got that. Let's just do O to Q at the same time, even though it's not asked for. And so this is going to be equal to 1, negative 1, and 3. Sorry if you can hear me fumbling around with something. I'm just opening the textbook to double check these as we go. I don't want to miss a section of working which we're dealing with. No. So we've got them there. Okay, I missed the bracket. So then we've got to find PQ. So we should go, well, P to Q. If I'm going to remember this off the top of my head, this is going to be P to O plus O to Q, which would equal O to Q, I've done it again, O to Q minus, because we need to swap these around. So to swap them, this is going to be O to P, which we have. And so in this space here, OQ is, I'm using this notation. So OQ, which will be our first thing, is 1, negative 1, and positive 3. And then OP is negative 3 plus, sorry, I've missed this negative sign here. So these will all be negatives. So let's just erase that and I'll put these negatives in first. So negative, 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 and then we had negative 3, positive 1, and 2. And so this will equal 3, 1 take negative 3 is 1 plus 3, which is 4. Negative 1 take 1 is negative 2, and then 3 take 2 is 1. So we've got that there. So that means from these 2 points, if I was to draw these, so from the origin we would have, let's just say P here, which is -3, 1 and 2, that's its coordinate, out to, now these aren't to scale and I don't have them on an axis, but we've got 1, -1 and 3, and then to consider this, I just want you to consider we've calculated P to Q, so you'll notice here 3 to 1 is a +4, 1 to -1 is a -2, and then 2 to 3 is a +1, and that is, that 4 lines up with this, the -2 lines up with this, and the 1 lines up with this. So a quick way to do these, final one is the modulus of these, so we could put this sum in here, but we've actually calculated the values, we may as well do it. So we will have PQ is going to equal the square root of 4 squared plus -2 squared plus 1 squared, which is going to equal the square root, I'll just do this square root here, and then let's get a nice straight line. 16 plus 4 plus 1, it's going to equal root 21, which we'll just leave as such. Cool, all done. Let's jump to the next one. So that might be the same for us. So this one here, we're looking at, our example is find the coordinates of C and D. So if we consider this, the vector AB, I'm going to give the symbol A. And so that's sort of saying this vector here, which we've done in blue, I'm just going to call that A, because that's sort of talking about this. Now, the reason this is beneficial is if I quickly draw these ones in here, and we call this point the origin, then technically we can figure out this A vector, and I've missed that off the notation. Then if we use this point B, we can just add this vector A to it. So if you consider this, if I wanted to find C, O to C, one of the ways I could do it is I could go, well, let's go O to B and then plus B to C. Now, we know here that because of the way this line is drawn, that B to C is going to equal this A vector. So once we figure out what this AB vector is, we're golden here. So our formula again, AB, I'm going to skip a step now because we sort of know this, and it's, actually no, let's put it in one more time just for practice. So go from A to 0, the origin, and then the origin to B. So this means that it's going to be O to B minus O to A is the easy way to do that. And so this in this vector, OB is -1, -2, and 2. Okay, and then OA, I've got to minus the OA, so I'm going to put minus in for each of them. We've got -2, -5, and 3. Okay, so A to B is going to equal here -1 plus 2 is going to be 1. -2 plus 5 is going to be +3. And then and then 2 take 3 is going to be -1. So this means that in my next one here, I can go, well, this is going to be OB, which is -1. Maybe I should write these out as proper vectors. Let's just move it out a little bit. Okay, so this one here, I'm going to just change to the textbook notation for space. So I hope you don't mind. So the textbook notation has our vectors up like this, and it's just, I personally don't mind this notation. I find when we're adding things, make it easier to put the individual elements in. But so negative, this is our OB vector, and then we're going to add it with BC, which we've said here is going to be equal to OB plus BC is that A vector, which we're just signifying with A. I'm going to just call this AB just because it's easier to do over here. And we had that was calculated at 1, 3, and -1, which means this whole thing is going to equal -1 plus 1 is 0, -2 plus 3 is 1, 2 take 1 is 1. So we end up with this next coordinate here is 0, 1, 1. Okay, last bit here. Okay, we're going to have O so we're going to figure out OD here, which is, if we look at this, we can use OC, or we could use, so looking at this, O to B plus AB is going to get me to D as well. So let's do that one because it's a scalar multiplication. So let's consider O to B because we've got a fixed coordinate that we know, and then we're plus 2 of these AB vectors will get us there. So this is going to mean that OB was -1, -2, and 2 plus 2 times 1, 3, and -1, which means, have we got room next to it? Yes, we do. This is going to be -1, -2, 2, plus 2 times 1 is 2, plus 2 times 3 is 6, plus 2 times -1 is -2. Okay, and that means this vector here is going to be -1 plus 2 is 1, -2 plus 6 is 4, and 2 take 2 is 0. So we're going to be looking at 1, 4, and 0. So I'm going to rewrite this as 1, 4, and 0, which means 1, 4, and 0 here. 1, 4, 0. All right, so this is good because you should notice here -2, -1, 0, 1. There's a pattern, -5, -2, 1. This is going down up by 3. So 3, 3, plus 3, perfect. 3, 2, 1, 0, perfect. Those coordinates are correct. We can see that clearly with the pattern. Now, final example question. We're looking at a parallelogram. So this one here, we've got to be really careful with we've got to be careful with how we draw our parallelogram. I'm wondering whether this app will let me draw a parallelogram. No, it doesn't look like it. Let me try one more time just in case it comes out. No, just a rectangle. Okay, so I'm going to have to draw these. All right. Now, whenever we do a parallelogram, we have to make sure we keep the naming conventions of them, which is we either go clockwise or anti-clockwise. It does not matter which one you pick. And so we've got this parallelogram, and so we've got AB is parallel to DC and they have the same length. So DC equals AB. So we're looking at these. If these are, a parallelogram has parallel sides, and as a property, the sides are equal in length as well. So I've tried to use different symbols there. So this means just looking at the diagram that our vector A to B is going to be equal to D to C. Okay, it also means that D to A is going to be equal to C to B. Either of these is fine, so we've got to work these out. So let's work out A to B first because we've got these coordinates. So we've got A to B, and I'm going to skip a step this time, is going to be equal to OB minus OA, which means that our OB vector is the position vector is gonna use the coordinates there. So from the origin, we've got 2, 0, -1. And then our OA vector is gonna be minus, and then we've got here -1, 2, and 1. And then this is, we're going to have 2 take -1. We're going to do these elements together. 2 take -1 is 3. We've got 0 to 2 gives me, 0 take 2 gives me -2. And then I've got -1 take 1 is -2. Okay, so this means if I go from A to B, A to B goes up by 3, down by 2, down by 2, perfect. So that works. So now we've got to work out, well, C, so AB has to be equal to DC. So let's work out what DC is. So D to C is going to equal OC, which we'll figure that out in a minute, minus OD. And this is equal to OC, we don't have there. We're going to find the coordinates of C. We're going to just pick 3 constants or 3 letters so we're going to pick A, B, and C for this, or we could use X, Y, Z. And then we've got minus our OD, which is 3, 1, and 4. Okay, and so this means we're going to get this DC vector is going to be A minus 3, B minus 1, and C minus 4. So we've got these 2 vectors here. Now, this is where I kind of prefer the other notation, is because we can look at them right next to it, but we've already suggested that AB is equal to DC, which means so if I use this notation here, I've got 3, -2, and -2, and this is equal to A minus 3, B minus 1, and C minus 4. So using these individual equations, I can go, well, therefore, A minus 3 equals 3, A equals 6. I've got B minus 1 equals -2, plus 1 to both sides, B equals -1. And then my last one here is C take 4 equals -2. I add 4 to both sides, I get C equals 2. So I've got these coordinates here. And so if I put these back in, I've got my OC, which is my coordinates of my C1. So therefore, OC equals 6, -1, and 2. Now, the next bit's actually, this is pretty handy. So one of the features of a parallelogram is that its diagonals will always bisect, which means this diagonal and this diagonal will meet, and the coordinates have to be the same for these. So if we go halfway between A and C and halfway between A and C and halfway between D and B, we will get the same coordinates. So we're going to consider this now. I'm going to go down lower. So midpoint of D, B, and AC should be equal. Now, to find the midpoint, we've done this previously in 2D vectors, and what you do is you pretty much you put you get your coordinates of the 2 points. So if we consider the midpoint of 1, 2 on just the Cartesian plane, and let's call this one 3 and -2. to find the midpoint of these coordinates, so let me just put a box around this so we don't mess this for our diagram. So this is just an example. All we do is we go, well, 1 plus 3, which is my x components, divided by 2, and 2 plus negative 2 divided by 2 will be my midpoint. So this will be 1 plus 3 is 4, divided by 2 is 2, and 2 minus 2 is 0. I should get 0 here, 2 and 0, and you would find that that's perfectly correct, because you would have 2 units in the y and 2 units, well, my drawing is clearly not to scale, but if you consider this x component from here, 2 to this here would be 1 and this would be 1, so 1 to 3, it would go across in the x direction by 2, and then this would go down by 2 and down by 2, and you would get to that point. Anyway, so the point I bring up now is we can use our coordinates of AC and DB to work these out. So if we have those coordinates, which we do up here, we can use them to work this out. So we've got, let's go DB midpoint, and that will be the coordinates of D, which we've got. So we've got 3, 1, and 4. Okay, these are all going to be divided by 2. That's how we find a midpoint. We add them together. And then I've got to add the B values together. Now, I'm doing this one first because it's D and B. We were given those coordinates. So B is 2, 0, and negative 1. And so this midpoint is going to be 5 on 2, 1 on 2, and 4 take 1 is 3, 3 on 2. So now a quick way to check that C is in the correct point is we go midpoint of AC, we're looking at here, which is going to be, let's put our A values in, which is, what do we got? A is negative 1, 2, and 1. Negative 1, 2, and 1. And these are all over 2. Oh, that's messy. These are all over 2 as well. And then we've got negative 1. What are we looking at? Our C point. So we've got plus 6, take 1, and plus 2. And this, you'll notice, negative 1 plus 6 is 5 on 2. 2 take 1 is 1 on 2. And we've got 1 plus 2 on 2 is 3 on 2. And so this, let's get a better colour, big tick, because these both line up, which is perfect. So midpoints are the same, which is a property of a parallelogram, but let's write it out properly because that's what we've got. The midpoints are the same. So diagonals of parallelogram bisect. Now bisect means chop in half. All right, there we go. All good.